Okay, today's lesson is on combining like terms. What does that all mean? Well, when you're doing the last lesson, you did evaluating expressions, which means you had some numbers, some letters, they were connected by addition or subtraction, or multiply and divide, and then you had to plug in the number and get a value. Okay, that's called evaluating. Sometimes we need to kind of clean things up first before evaluating. It makes it a lot easier. For instance, if I gave you this on the last lesson, you would have to have plugged in the value for x here and here and here, and then done your multiplications, and then added and subtracted all the way across. So your using the order of operations and stuff would have taken much longer to do. So what we're going to do is we're going to clean this up a little bit, and that's what we're going to work on today, how to really clean this up, or how to combine like terms. Okay, so the terms of a big long string thing of an expression here are all the little pieces here, and you kind of, instead of seeing this as 7x plus 3 minus 5x and so on, I want you to see this as a 7x, a plus 3, a negative 5x, a positive 8, and a positive 4x, and a negative 1. So kind of see these as extra pieces, kind of sliding tiles, if you want to think of it. And all we're going to do is add them. So everything that looks like a subtraction now magically has become a negative number. So we're going to kind of add as we go along anything that's alike. So what do I mean by alike? Well, there's two different kinds of terms. There are variable terms and there are constant terms. Variable terms are just exactly what these pieces are with the letters attached to them. So in this case, 7x, negative 5x, and 4x are all considered variable terms because they are the ones with the letters attached to them. Remember that the letters in algebra are the variables. Okay? Constant terms don't have any letters attached to them per se. They just are numbers by themselves. So in this case, the 3, the 8, and the, again, negative 1 are all what's considered constant terms. They can't change no matter what x is equal to. 3, 8, and negative 1 will always continue to be 3, 8, and negative 1. They will not change. The numbers in front of these variables have a special name. They are called coefficients. So that's why it's kind of underneath the variable terms. So 7, negative 5, and 4 are your coefficients. So when we combine like terms, what we're going to do is we're going to put together the coefficients, the numbers in front of the variables, of the variable terms, and then we're going to combine all the constant terms together. And then we're going to write it as one expression instead of this big, huge, long string of expression. Long expression. All right, so we're back to the original example from the top. And I'm going to highlight all of the variable terms. So we have that one, and then we have this last one. Okay, so 7x, negative 5x, and 4x. So notice I'm not thinking about addition or subtraction. I'm thinking about it as positive and negatives. So I have a 7 and a negative 5, which is 2, and then 4 more. So this is 6x. Notice the x's are just kind of along for the ride. We're just combining the numbers in front of it. Now the numbers left over, 3, 8, and negative 1, we add those together. So 3 plus 8 is 11, minus 1 is 10. Now when you get 10, when you get a positive number, I need something between them to show that they're not the same term. So we still have two terms. Okay, so we put a plus sign in front of it. If you come out to be a negative, then it'll look like a subtraction problem. When I'm done, I don't have to do anything. And I'll show you that when we get to some problems like that. All right, so let's just do let's just start with number 1. Okay, number 1, I'm just going to combine the 3 and the 6 because I have those are my only, my variable terms are the only terms I have. So I put these together and I just get 9x and I'm done. Okay, number 2. Okay, I had 9a and I took away 10a. Or if you want to think of it this is 9 plus a negative 10. Think of it that way. Okay, so 9 and negative 10 is negative 1a, or negative a. The SOLs are going to put it as negative a. It's understood that if I asked you how many a's there were here, you would say 1. There's 1a. So that's why they don't put a 1 in front of it. If it's any other thing other than 1, like a 2 or a 3 or 4, you got to put it in front of the letter. But if it's not, then they write it without the number. If you put the number in on a quiz or test, I won't mark it wrong, but just understand when you see it on the SOLs, hopefully you won't get confused by it. All right, so let's do number 4. So number 4, we try to do our coefficient terms first. Our variable terms first. So we're going to do that. There's nothing to do there, so I just have to write it. Negative 6w. And then I have to just put the 9 and the 5 together, which is 14. And since it's positive, I'm going to put a plus sign there. And I'm done. Okay, number 6. Again, highlighting just the variable terms. I got a 5 and a 7, so that's 12h. And then I've got, again, I want you to read this as negative numbers. So this is negative 6 and a negative 8, which is a negative 14. And you're done. All right. Number 8, I've got A's and B's. So keep the A's with the A's and the B's with the B's. Okay. So I'm going to have, I have 26A and negative 4A. 26A and negative 4A is 22A. And now I've got a 2B and a 10B, which added together is 12B. And again, I put a plus sign if I get a positive answer. All right, that's it for that page. Mine's in a two-sided. Yours, you just flip over. All right, so now we're going to talk about what happens when you have exponents. Don't let the exponents scare you. It's just like what we've been doing with regular x and regular y, except now we have x squareds, n fifths, c cubed, all those, but it's done the exact same way. If the letters to the exponents match, you put them together. So in number 9, we'll keep it simple. I've got 5x squared plus 7x squared. That's going to give me 12x squared. Again, all I'm doing is putting those coefficients together. That's all I'm doing. Notice the exponents do not change. You do not change exponents when you're adding or subtracting. You only change exponents when you're multiplying. There's no multiplying going on here. Everything is just either adding or subtracting. Okay, so we don't have any multiplying going on. All right, so number 10. I got a negative 15 and a positive 4. So negative 15 and a positive 4 is a negative 11. And again, I just write down my letter to the exponent. All right, so here's a good example. Number 12 has k squareds and has k's. So let me highlight the k squareds. Then we're going to highlight, or actually I'll underline with my red pen, the k's. And then I'm going to leave the 7 alone. The constant. All right, so I've got 8k squared and a negative 2k squared, so that's going to give me, 6k squared. Notice my my exponent did not change. This little guy here did not change. Now I've got some k's. Remember, if you don't see a letter, a number in front of the letter, it's a 1. So this is negative 1 and negative 5, which is negative 6k. I don't have any other constants other than the 7, so I just tag it on. Plus 7, and I'm done with the problem. So the k squareds are different from k's, which are different from no k's. So we keep them all separated. All right, number 14. Number 14's got some x squareds, and it has some xy's, and that's it. So it looks like I have an x squared, but no other x squared, so I write that. And I'll go back here at the bottom, look. There's a 4y squared, but no other 4y squareds, or no other y squared, so I'm going to put that down. This guy in the middle is the only one that I have to worry about. So positive 2 and negative 7 is negative 5xy. And I'm done. Okay. All right. I'll do number 16. Number 16, it looks like I have, let me highlight again. I got an x squareds. I've got some x's, and then I got some constants. So I got all 3 things to do. All right, so 4x squared and negative 3x squared is just an x squared. Okay. I have a 2x and a 8x, which is 10x. And then I've got a negative 7 and a negative 6, which is negative 13. Again, you'll have to use your calculator if you're not good at your adding or subtracting positive and negative numbers. You'll just have to use your calculator to do that. All right, so the last thing, number 18, I'm going to do, there's 4 problems here, but I think you'll get the hang of it with just one. Perimeter means adding all the sides. So this is a geometry example of how to use your algebra you just did. So I'm going to add up all my sides. So I'm going to put down here 17 minus a plus 5a minus 1 plus 4ab. Okay, so I'm just adding. I'm going to circle these pluses so they don't get confused with the other things. So I'm adding all 3 sides together. So all I'm doing now is combining like terms. So this 4ab would be listed first because it has the most going on, and so we always list that first. Just like I forgot to mention that when you're doing problems like this one, the highest exponent gets listed first. So see, just like this k squared minus 6k, the k squared is listed first. We try to list our highest exponent first. All right, and this has got the most going on, so it gets done first. So now I have a negative, remember this is a 1a, so negative 1a and 5a is 4a. Then I've got, looks like a 17 and a negative 1, which is 16. And that's the end of this problem. So hopefully you kind of get the idea. If you have any issues, just call me over or have me come and explain a couple more for you if you need it. Thanks.